This is all about cathode ray tubes, which are just old TVs. Inside all those old TVs, thermionic emission makes some electrons. Cathode and anode push them around, and some deflection plates then deflect them onto a screen, steer them around, and color is made and TV is watched. So your anode here is just something that's positive. Cathode, something negative. Easy. Look, positive and negative, plus, minus, anode, cathode, all just mean the same words for the same thing. So the way I remember anode is plus is, I think of A for addition, A for anodes, and cats are negative. Everyone knows that, because they carry those horrible toxoplasma gondii parasites, and they're trying to take over the world. And everyone knows cats are evil. Well, they're just not as good as dogs. I have nothing against cats, really. Okay. So, speaking of evil cats, can you name which side of this battery is negative? And then, which side is the cathode and anode? And, well, if you think that this plus one is the anode, you're absolutely right, because this one here is a cathode. The thing about thermionic emission you need to know is that it's just a big electron cloud factory. Basically all you do is you get a wire, you connect it to a battery, so because there's no resistance it heats up. When the wire heats up you get this lovely cloud of electrons around it, and you really notice that when you put the whole thing in a vacuum, because the electrons don't really collide with air particles when there's not that many of them, so you can get this lovely build-up of air, of electrons around the wire. So that's this lovely electron cloud. Once you have those electrons sitting around waiting to be used, then you got your raw material for cathode ray tubes, X-ray machines, all that jazz. It's all just playing with electrons. This is where you get your electrons from, though. Okay, so thermionic emission, if you want to give it a fluffy definition, it's the emission or release of electrons from the surface of a heated metal. What you need to do then is, once you've got your electrons, you're going to manipulate them. You're going to move them about using forces, electric field forces. When you do that, let me see, let's just draw a little thing. So what did I have to make some electrons? I had a bit of metal. Let's just put a battery here. That's a little cell. Actually, I'll tell you what, I'll do a little coil to get lots of metal just in one place. Nothing really that special about the coil. It's just metal. Alright. And then I'm going to get some electrons flying around there, because I'll just see this electron cloud. These little dots will be electrons. Because it's heating up, because there's no resistance there in that wire. It's like short circuiting a battery. You can try this. Stick a wire across a battery, it'll heat up and burn your hands. You won't get electron cloud that visible though, because of unless you do it in a vacuum. But then you won't be able to breathe. Don't die. What you're going to do with this electron cloud is shift these electrons around. Now you can't blow on them or ask them nicely to move around. You're going to need some forces. So the secret is to get a big metal plate, flick that on the negative end of the battery. I'll make this a little bigger battery because I want to give this a good whoosh. I'll bring this over here. And I'm going to make this a positive then, because this is the positive end of the battery. I'll say, or what's the fancy name for that? The anode. Yes. And this is the cathode. Yes. I've just made a giant flippin' cathode right there. Look at that. Excellent. So many minuses. Just minus crazy. And over here, we're all plus crazy. I've just made loads of pluses like that. And that means that I've got this giant minus and plus cathode and anode surrounding the electrons. So that's going to do some convincing. That's going to make these electrons here, which are negative, follow that classic electron rule, which says that or just rule in general, that opposites attract, as in plus minus love each other, and like charges repel, as in bleh. So look at that. If I drop this anywhere near here, it's getting pushed by this guy and pulled by that guy. Excellent. There we go. I've got a push and a pull. So definitely they're going this way. There's no other. There is no choice. If I wanted to really like hit someone in the face with this, if I was to put a guy there as a target, it wouldn't really work at the moment because the electron is going to slam into this plate, go down the circuit into the battery, and I'll probably never see him again. So what we're going to have to do here is make a little gun barrel. So all you do is just very cunningly just put a hole in there. Let's make this all 3D like. So these are now big metal plates. So yes, most of the electrons will probably hit the plate and go back down, but some of them might go through this oddly shaped hole. It's probably better in your real TV. It might fly through that hole, and before they can slow down and get pulled back to the pluses, it'll hit this guy in the face. There you go, electron gun, absolutely easy. So that is what is inside your telly. Alright, you just got to bear in mind that all this stuff has got to be in a vacuum. Just be careful if you're throwing out a TV because vacuums can implode. If you just tap the glass, you get a fairly decent explosion like that. Now, once we're firing electrons and our gun is loaded, aimed, and primed, all we're going to do is deflect the beam, because right now, if we shoot those electrons into a screen, they make it a sizable and impressive dot if they were to be bombarded onto some kind of fluorescent surface. But we want more than a dot. We want to watch TV. So we have to move them up and down, track them up and down the screen. You do that with deflection plates. The way they work is the same kind of thing with if you've ever brought a balloon near a tap, something that's staticky, or you rubbed it in your hair, you find you can bend the beam. And that's just the exact same again. Like charges repel, and these guys here are opposites, so they attract. So if you can imagine, like, I'm just kind of putting a balloon up and down here to steer the beam. Imagine this, say, electron beam was water coming out of the tap, and you're looking at it on here sideways. You could bring balloons up and down to kind of steer it up and down, and then put balloons right and left to steer right and left. So they've done that now in a less balloony way. They've put in electromagnets here, and electromagnets are just a magnet you can power up and put on 50%, so you can steer it a little bit left, you can steer it loads left, and that's what these little plates are. These are deflection plates. So once you have a Y plate, an uppy downy plate, an X plate, a righty lefty plate, you can put it basically anywhere on the grid. So once you can steer it up and down a grid, you just divide your TV screen or your grid into a little a grid, and if you coat it in phosphorus so that when the electrons hit it, they'll make this really cool little blip, and you see a little dot and then another dot, and every time you kind of pinprick each pixel, you'll get a little dot for an instant. And let's just skip every second one though, so we don't get them mixed up, and then we track back then. So you're going to cycle up here along your screen. I'm not quick enough to do a dot in every one, but you get the picture. So you just track along here. This is called tracing. Now it does it incredibly fast. We're talking 50 hertz. That's 50 cycles per second. Now it might not seem that impressive, but actually, to be honest, going through all those 50 times a second would be impressive. Your screen has got like possibly a million or more of these. So that's pretty impressive. Going through that many in 1 second would be amazing. 50 times a second, absolutely amazing. How they came up with this TV thing blows my mind. And if you want to add some Technicolor, all you do is instead of having one little blip here, instead of a little blip every time it hits, you're going to have 3 optional blips. You can have red, phosphorescent material, green, and blue. And with those 3 colors, you can make up everything. They're the primary colors of light. Never mind yellow, that was a play skill. That's not a real primary color. It's RGB, red, green, blue. Something else you might see on your TV menu if you push the wrong button and can't get the volume thing to work. So there is how it works. You might thought that looked like an eye. It does. But if you zoom right in, you can see it's just RGB, red, green, and blue pixels, and it just hits one more than the other to pronounce it. And you can see that's pretty cool. Look at that. Alrighty, and that's pretty much it. So again, just in summary, you've got negatively charged cathode there. You have your heater to give you a fresh supply of electrons. The negatively cathode pushes away the electrons towards the anode here, which is a happy plus. It flies through here. Now there is sometimes a second anode, this kind of thing, but that's just to focus the beam. It's just a fancy addition. I wouldn't worry too much about that. Then you got your 2 plates, your uppy downy plate, your Y plate, or vertical deflection plate, your horizontal plate, or X plate, or lefty righty plate, and that shoots your electrons over this way, and they'll hit the screen there, and you do get a nice phosphorescent coating in that, because you actually can't see electrons. Don't think you're seeing the electrons go blip. No, you're seeing the phosphorescent material emit light when it's struck by electrons, and that's it. It just goes up and down. That is cathode ray tubes.